Hi, Sanjay here. So in this little segment, I'm trying to give you an oversight of our demos. The problem we have is we are not a one-trick pony. We do almost everything better than the others, short of scaling up to kilowatts, which we can easily do because we are demonstrating we got the physics right, and we are not merely upscaling the mistakes of G to kilowatts level like we believe Vitricity and everybody out there without exception is doing. And they will get stuck forever, as I explained in a previous video. So we have a lot of demos. We do almost everything. We even do Qi better than Qi. And I'll give you an example of that. But we also don't like to edit our demos because we feel that reflects dishonest intent. So people jump cut and make some edits and fool you basically, and we have tried never to do that. So all the original videos are unedited and usually multi-camera. So but in this one, just to save you time, I'm going to do a quick edit. You can go back to the original ones and see that they were unedited and nobody fooled around with any of the videos. But here, to save you time, I'm going to give you a quick drive-by talk of our demos and show you the basic principles underlying it and what we're doing. So on the screen you'll start seeing a short video which I'm playing right now. So first of all, as I've explained, we reinvented the magnetics. So the traditional spiral coil and spiral coil, though giving a good coupling, is very alignment sensitive, and it can't tolerate metals in the neighborhood, which is a problem in phones. And the receiver coil has 10 times the resistance we have. So this is one of our older boards with manual tuning, and I'm placing a typical 5-watt Qi coil with a halogen lamp so you can actually see the power, and you see if it's centered it works, otherwise it doesn't. And as I explained in a previous video, that is also the worst possible location because in a phone it's pressed against the battery, a heat trap is created, and the battery actually dials back on the accepted power to barely 3.7 watts. And the battery life is still halved, and you can't even see the screen while driving, and you want to do that in the modern age. So the way we did it, as I explained, is two opposite polarity coils. It's all proprietary. They create a flux laser, and a tiny coil which could be at the bottom of a phone or in fact any known device including a laptop can pick up everything, and the case of the phone can be metal again, which actually helps dissipate the heat, not only due to wireless charging but due to the microprocessor and all other components. So they can go to blazing fast speeds now. So our principle is different. It's inherently alignment friendly. You can move the little tiny receiver coil and the flux lines tend to follow it, and you can parallel several of them for higher power like we are proposing for EV. And a metal, it doesn't matter because the flux is horizontal, not vertical. And here's an example of a metal body small toy car where I put a tiny coil, and you can see there's no problem. This is the manual version of our transmitter, and you can move it up and down. Inherently alignment friendly, our coil structure, and actually you can move it sideways and it also works. I can't tell you how. Now that tiny coil can be put in a phone, for example, and it can be charged vertically at any angle. There are a lot of patents on this. I can't exactly explain how we did everything, but you'll have to believe me here. So and here's a tiny coil with a 5-watt halogen. The coil is only 0.4 millimeters thick including the copper, so you can't imagine what a thin coil, and that gives you an idea of how powerful the flux is in that area. And you can parallel several of them. So the reason I put halogen lamps is people fool you with charging icons, and lamp gives you a very visual indication of the power. It may look a little engineering and not very finished for investors, but that's the correct way. And we can do dual Qi, as I'll explain. In a car, two phones right next to each other. We can charge multiple phones vertically. So here is one of them coming up. This is our automatic transmitter which does everything, and you see I can turn it around and it'll work. It won't even dim because we have several proprietary control loops working. It is much more complex than it looks, and I can put two of them, and it doesn't mean that one becomes dim while the other lights up or they share the power. We actually generate more power when two are there or when three are there. Here's the high power mode, which I have proposed for a laptop. I don't have the laptop demo here, but we had demonstrated that earlier. And this will give you a regulated output voltage. This is the one we are planning to use for EV charging. It will be 400 volts in roughly and 400 volts out. And you see the flickering that indicates communication. The blue light is flickering and there's intense power. And I show this in live demos and I ask them to touch that little tiny receiver coil. It doesn't even get hot. It is so tiny, can you imagine? And this is at a 12 volt input applied to the transmitter. Can you imagine what happens when we scale this to kilowatts level and higher voltages which are required in EV charging? So, but then I also told you we introduced secret sauce. Resonance is extremely tricky. You have to unlearn my 7 or 8 books to understand resonance, believe me. Here's just a small example. Whenever you move the coil, like it could be a car with high clearance or different alignments, the peak changes. And unless you realize that and adapt to that, you cannot compensate, you cannot switch optimally, you cannot get maximum power. So these are MATCAS simulations which I have shown and they have been tried out on the bench. So this is just a little animation to show you that the flux lines prefer the magnetic material and follow it. Now, the original patent, which got it all wrong, was the Amway patent, which started the Qi consortium. The Wireless Power Consortium is based on a patent still assigned to Amway. And they basically said tune both the receiver and transmitter to 100 kilohertz and you'll get the maximum power. This is radio frequency style of thinking, but it doesn't apply to conditioned systems, to coupled systems. And here is a more recent 2019 patent by Halo Qualcomm. The entire Qualcomm portfolio was sold to Vitricity. So everybody has made the same mistakes. And you can go to Vitricity's homepage and they still talk about tuning the receiver and transmitter to exactly the same frequency, thinking that that somehow applies to a closely coupled system. It does not, and you are in a big mess. So admit it, Vitricity has been struggling with EV charging also for 10 years and have almost nothing to show. This is what the Qi consortium said. If you bring them together, the resultant is a resonant peak of 100 kilohertz fixed. Wrong. As I've shown in several MATCAS simulations, you get 2 moving peaks. Come to me and I'll explain it to you. I explained it at the IEEE seminar recently, and there was a lot of people there, including an Apple engineer, by the way. And I also told them that you have to switch on the right side of the curve, and if you got multiple peaks, you don't even know where to switch. So a prerequisite for any secret sauce is the single resonator, which we have patented and nobody can step on our toes. And now we can also put our tiny coils on the underside of a car and park freely because we adapt to different alignments and coupling. Our firmware was written in a way that it is overnight scalable to kilowatts. I don't like to reinvent the wheel 100 times. So I told my guys, you can park a Hummer, you can park a low clearance car, the coupling changes, but we adapt to it at any power level, at any input voltage level. Yeah, the rating of the FETs and all will have to change, but the firmware still works at 3.3 volts and it is going to remain exactly the same. So sorry to say, the work we have to upgrade it to kilowatts level is nothing almost. We can do it in a few months, but we have to get the copper and low resistance coils and for that little higher current. So that is the only thing, and you can't adjust the car by moving it like you would do on a phone. So this is the option. If you want to implement EV charging, you have to adapt to different couplings and different alignments, and the way the Society of Automotive Engineers, I believe, is doing it, and Vitricity is doing it, and everybody is doing it, is wrong. First of all, they're based on the wrong double resonator approach, which I have explained. They will put them in a swamp for another 10 years. We have figured it all out, and the basis is the single resonator, which is patented by now, dating back to 2015 or 2016, which prevents any recovery from all the big guys like Google, Apple, even Society of Automotive Engineers, though we'd love to work with them, of course. This is showing you better than Qi compatibility. We can do 1 Qi, we can do 2 Qis. We have the best foreign object detection. You put a coin and it works. And this dual Qi is something where you can put 2 phones right next to each other in a car while you drive with no spacing between the coils. And of course you can charge the phones vertically, multiple phones with an appropriate case. Or now look at the wearables. You have seen all these clumsy Qi structures to charge wearables. Hey, we can do it on the side on a standard Qi transmitter. We could do this in 2016. Can you imagine what we can do today? And Apple is still trying to heat up the entire watch by putting it flat on very proprietary transmitters. So just think what we can do as of today.